In this session, we will discuss inverse functions. The inverse of a function fx is the function that undoes what fx has done. It means that if we have x and a function fx is applied unto that x to give y, then f inverse of x, written as f power minus 1x, f inverse of x is a function which when applied on y gave us x. So this function f inverse basically undoes what fx has done. We can take few examples. For example, if we have a number 5 and there's a function x square, when x square applies on 5 it gives us 25. The inverse function of x square is square root of x. So when square root of x applies on 25, it gives us 5 back. Similarly, if we have a number 5 again and we apply a function multiply by 4, so our answer is 5 times 4, 20. The inverse of multiplication is division, so divide by 4. So when this function is applied on 20, it gives us back 5. So this is the idea of inverse functions. There are few points to remember. The first one is when a function f is applied onto its inverse, or when a function f inverse is applied to function f, the resultant is always equal to x. For example, if we have a function fx is equal to x square and then f inverse of x is under root x. Now if we apply f inverse on fx, it means that first of all we have to write fx is x square, and applying inverse function on that is basically applying the square root function. So square root, and you know that square and square root cancels each other, so our answer is x. Similarly, if we apply f on its inverse, again f inverse of x is under root x and f is square, taking square, so square of under root x is x. Then we have the domain of f inverse x is the range of fx, and the range of f inverse x is the domain of fx. So if you know the domain and range of the function fx, you can easily work out the domain and range of its inverse. And finally, an inverse function f inverse x exists if and only if the function is a 1-1 mapping. It means that for a many one function, inverse does not exist. Let us take an example and see how we can find the inverse of a function step by step. If a function fx is equal to 3x minus 1 and we are asked to work out the inverse of this function, we have to follow the following steps. In first step, we will write the function as y is equal to, so instead of fx, this will be replaced by y. So we will write it down, y is equal to 3x minus 1. In the second step, we will interchange x and y variables. So we will get this y is replaced by x and this x is replaced by y. So our function become x is equal to 3y minus 1. And finally, we will rearrange to make y the subject. To make y the subject. So 3y minus 1 is equal to x, or 3y is equal to x plus 1, or y is equal to x plus 1 over 3. So this is our inverse function now. Therefore, f inverse of x is equal to x plus 1 over 3. Let us have a look into the function fx is equal to x minus 2 whole square plus 1 and its graph. This function fx is equal to x minus 2 whole square plus 1 is defined for all x belongs to the set of real number. So here we have to answer a few questions. The first one is, what type of mapping is fx? It means that whether fx is a one-one function or a many-one function. So clearly you can see if you take any value of y, for this y value we have two x values. So it is not a one-one function, so it is a many-one mapping or many-one function. Secondly, it said that work out the coordinates of the vertex. So here we have vertex, and the function is already written in the completed square form. Fx is equal to x minus 2 whole square plus 1, and from here we can get x is equal to 2 and y is equal to 1. So this is the x value and this is the y value of vertex. So 2 and 1, these are the coordinates of vertex. Then what is the domain of fx? The domain of fx is already described here. X belongs to the set of real number, so all real number. So domain is x belongs to the set of real numbers. And then what is the range of fx? Range of fx means the y values. So you can see that this vertex is the minimum point and y value is 1. All the values of y, this is the minimum value, and all the values of y are 1 or more than 1. So the positive y-axis. So therefore the range of fx is y is greater than or equal to 1. So this is the range of the function. Now the next question is, does the function has an inverse? So technically yes, this has an inverse, but from the definition of a function, as we know that the inverse exists if and only if the function is a one-one function. So this function is a many-one function. Therefore, for the given domain, x belongs to the set of real number, this function has no inverse. So the answer is no for x belongs to the set of real number. So there is no inverse if this is our domain. And the next question related to this one is, how could you change the domain of this function so that it does have an inverse? Okay, let's have a look into the function here, and if I draw a line of symmetry here at vertex and only focus on this part of the function, for example. Okay, let us resketch the function for the part I have described. So that is the part of the curve, the one I have highlighted here. This is vertex with coordinate 2 and 1. Now you can see that for any x value, there is only one y value. Therefore, the curve, or the part of this curve, which is also represent the function fx is equal to x minus 2 whole square plus 1, is 1, 1. So if we change the domain of this function as that the value of x is greater than or equal to 2, then we can say that the function has an inverse for this given domain. You can also focus on this part only in the same way. Therefore, we can change the domain, either x is greater than or equal to 2 or x is less than or equal to 2 separately. This will give you this part of the function, and this will give you this part of the function, and both basically represent the same function, fx is equal to x minus 2 whole square plus 1. And then we can say that now, because the function is 1 1, therefore the inverse of the function exists. And finally, finding the inverse of this function, x minus 2 whole square plus 1 fx. So in the first step, we will write the function in the form of y is equal to, so y is equal to x minus 2 whole square plus 1. Then interchange x and y variables. So x is equal to y minus 2 whole square plus 1. And then rearrange to make y the subject of the formula. So y minus 2 whole square plus 1 is equal to x, which gives you x minus 1 is y minus 2 whole square. Taking square roots on both sides, y minus 2 is equal to x minus 1 under the root, or y is equal to x minus 1 under the root plus 2, which is the inverse of the given function. So f inverse x is equal to x minus 1 under the root plus 2. That's all for now. See you next. Take care.